we're going to go right 10, left 10, up 10, and down 10. And we usually put a point out there. And then y'all usually complained about drawing these circles. You said, oh, this is so hard. This is so hard. Mine doesn't look like a circle. So you kind of just, I kind of just start to sketch it, and then I kind of go in. It should not look like this. It should not look like a square with rounded edges. Just do your best to sketch in a little circle. So to be real honest with you, most of you don't really know anything about polar coordinates really yet. You know a little bit, but you're going to be much more familiar with graphing in X's and Y's. Now I'm going to go ahead and tell you how you would graph R equals 10, and we'll get to this later, but this is a really good time since I already have it in rectangular form. If I were just graphing and I left it in polar form, this says the radius is always equal to 10. So in polar form, the polar equation says the radius is always equal to 10. It does not tell us anything about theta. So that means theta can be 30 degrees, theta can be 45 degrees, theta can be 90 degrees, theta can be 100 degrees, theta can be 199. So if you go to the right 10, and you pretend the radius is 10, and it is, and you would rotate and put a point. Go to the right 10, rotate and put a point. Go to the right 10, rotate. So theta is everything. So right 10, put a point. You see how you kept going to the right 10 and you rotated any amount of theta. There's no restrictions on theta. Theta is all real numbers, and that would create all those little points that have a radius of 10 and the angles of all kinds of different measurements. So that's how you would actually graph it if you were graphing it in polar form. And we'll graph a bunch of equations in polar form. Right now we're going to go back to rectangular, make sure we can switch back and forth because that's usually an issue. All right, 62. So 62 is in polar form. It says that theta is equal to pi over 3. So this one's kind of the opposite. This one doesn't have r in it. So it means your radius can be any length. Your radii of your polar equation is anything, all real numbers, but your angle of rotation always has to be pi over 3. So let me just show you the polar part of that. This is not what we're doing today, but I'll show it to you. So if theta is pi over 3, what degree is pi over 3? 60. So you would go to the, let's pull up a polar graph. Just want to show you something about polar graphs today. So if you were to graph this one using the polar graph, just watch me because this is not what you're doing, but I want to teach you something today. If you were to go to the right 1, because your radius is all real numbers, well, let's just go to the right 1 and rotate pi over 3. That would put me here, right? If I have a radius of 2 and my theta is still pi over 3, then that puts me here. If my radius is 3, but my angle of rotation is still pi over 3, then that puts me here. If my radius is 4, my angle of rotation is still at that constant pi over 3, that puts me here. So what's that? What type of graph is that going to create? That's going to create a line. Okay? So when your angle is constant and your radius changes, that creates a line. When your radius is constant, like in the first one, but your angle changes, that creates a circle. So it's just really different thinking because we have always thought in terms of X and Y. But we're going to get to the graphs. That's what we're going to do on Thursday. We're just going to start graphing every type of polar graph we can find out there. And we'll spend more time graphing polar graphs. But we want to turn this one into X's and Y's. All right, So how we do that mathematically is if we just have a theta and nothing else, we can't multiply both sides by r. That's not going to help us. We don't have an r to begin with. But we can take the tangent of both sides. We can take the tangent of both sides. And the reason that this is helpful is because tangent is equal to y over x. The reason taking the tangent of both sides is helpful is because the tangent value is calculated by doing y divided by x. And we're trying to turn our equation into x's and y's. That's why we're using tangent. Cosine or sine wouldn't help us because cosine doesn't have y and x in it. Cosine just has an x and sine just has a y. All right, what can y'all do now? There's something that I don't need to teach you that you already know how to do. Y over x equals the square root of 3. She is correct. This is where y'all just get dumber before you get smarter. I don't know what happens to teenagers at the age of 15, 16, 17, 18. So tangent of theta turns into y over x. And oh my gosh, you're supposed to be able to find the tangent at pi over 3. Yeah, the tangent pi over 3. I believe that's square root of 3 over 2 divided by 1/2. Yep, that's square root of 3. Okay? Now, how in the world am I going to take y over x equals square root of 3 and make it turn into a line? Square everything. My gosh, why would you think to square everything? Why would we do that? Because why? We're not finding the radius. Okay, does that help? We could multiply both sides by x, or we could even cross multiply, which does exactly the same thing. Okay, she said multiply both sides by x because we don't want an x to be in the denominator. Wow, have we ever talked about that? We don't want anything to be in the denominator. So that's going to give me y is equal to the square root of 3 times x, which happens to be a linear equation. Okay, and a lot of people wouldn't think that was a linear equation because it has square root of 3, but the square root of 3, guys, is just about 1.7. It's just a number, okay? And that number would be like your slope, and your y-intercept would be 0. And then we wouldn't have this polar graph anymore. I don't know if I can cut it out, but I'll try. Cut, go away, the line is still there. And so then you would sketch out a y-axis and an x-axis, and your y-intercept would be 0. And then you would rise and run 1.7 over 1. And you would get that same line that I had on the polar graph. Whew, y'all are scaring me. Y'all driving around in vehicles? So if you go up about 1.7 and to the right 1, you can think of your slope as 1.7 over 1. That would be the same stinking line we had on the polar graph. Same line. It's like going from Spanish to English. This is English. Polar form is Spanish, or whatever language you're not familiar with. Okay, great. Moving right along. Any questions about 62? WebAssign's going to be fun for this section. I can't wait.
Do we have one next week?
I will not give you one next week, but I'll give you one the next week. All right, next equation. R cosine of theta equals 7. How in the world can we change R cosine of theta equals 7 into rectangular? Now, I know a while ago I multiplied both sides by R, but in that first equation I did not have R cosine of theta. So R cosine of theta is special. It's really, really special. If you took notes yesterday, in your notes I wrote that x is equal to R cosine of theta. So anytime you see R cosine of theta, that gives you the right to replace it with an x. And if you try to multiply both sides by r like Luke might, you might just get this giant mess because you don't know what you're doing. So you may want to know what you're doing. R cosine of theta always turns into an x. R sine of theta always turns into a y. So look, another linear equation. Oh, we learned how to graph this in the 7th grade. X is equal to 7. That means I go to the right 7. And we would have a nice little vertical line. X equals 7. Please tell me that all of you know x equals 7 is a vertical line. Great. Sometimes I rethink my profession. I'm kidding. Only like 3 days out of the year. Only like 3 days. Today would be one of those 3 days. Because y'all are sitting here like. Alright, y'all got 64? Alright, moving right along. 66. Y'all got that on video. I just said sometimes I rethink my profession. Alright, please somebody not make me rethink my profession. You could multiply both sides by r, but that would make the problem much harder than it really is. So let's play on the secant. Okay, I agree with change secant into, but then what you said after that, I cannot believe you just said that. But I agree with the part that said change secant into. You said change secant into sine.
Oh, sorry. Long day, man.
You were on the right track, though. All right, so turn secant into 1 over cosine. And then anytime you see a cosine or a sine, you just replace it with x. Okay, so this is really r equals 6 over cosine. You could have skipped that step, but I was just trying to make sure everybody was caught up with me. And then you could cross multiply or multiply both sides by cosine, and you would get r cosine theta is equal to 6. And then that r cosine of theta pops up again, and r cosine of theta turns into an x. If you had r sine of theta, you would turn it into a y. So I'm looking into my crystal ball, and I see on the next test that we're going to take that most of you are not going to be able to convert polar equations to rectangular equations. I just have this feeling, unless you practice. So x equals 6 would be the vertical line to the right 6, and you would graph it. So if we had this same problem, except it was 6 times cosecant, then we would turn cosecant into 1 over sine. We would do the same thing. We would have r sine of theta, and we would turn that into a y. And what does a y equals equation look like? It's a horizontal line. Okay? So use that in the near future when you're working out problems. All right, number 68. Now, this one's a little bit tricky because you have an r on one side and you have a cosine on the other. Listen. Shh. You have an r on one side and a cosine on the other, but there is no way possible that the r and the cosine are ever going to get multiplied together. Okay? So this would be a really good place where you would want to multiply both sides by r. This would be a good situation where multiplying by r would be helpful and not harmful to your health. So then I end up with r times r, which is r squared, and then I end up with r times the cosine of theta. And remember, this whole time you're going, hey, I've got to turn this equation into x's and y's. So now r squared turns into x squared plus y squared, and r cosine of theta turns into x. Okay, now the algebra 2 begins. Okay, we know that this is a circle. We know that it's a circle because it has a positive x squared and a positive y squared, and the coefficients are the same. We just got to bring that little x over to our left-hand side, and we've got to do a little completing square. All that stuff we learned so much about. So we're going to do x squared minus x plus y squared equals 0. You're going to put your x together with your x squared. If you had a y, you would put it together with your y squared. We're going to complete the square with the x's only, because the x's are the only ones that have an x squared and the x, so you don't have to do anything with your y. Anybody remember how to complete the square?
No.
You take the number in front of your x term, which is a negative 1, you divide it by 2, and then you square it. You take the number in front of the x term, you divide it by 2, and then you square it. That's going to give you positive 1/4. So you're going to add positive 1/4 to your x's. That's going to create a perfect square trinomial. All right, your little plus y squared just comes on down. And if we added 1/4 to the left-hand side to balance that out, we have to add 1/4 to the right-hand side, and 0 plus 1/4 is 1/4. Now your trinomial will factor into a binomial squared. So let me remind you how to factor. You take the square root of x squared, which is x. If it's a perfect square trinomial, the only thing that you take from the middle term is its sign, and so that sign is negative. And then you take the square root of 1/4, which is 1/2, and then you bring down your plus y squared, and then you bring down your equals 1/4. Now I'm going to go to the next screen and write this so I have a little bit more room. So let me repeat what we did. We took the negative 1, which was in front of your x. We divide by 2 always. We square always. We take that number we get, we add it to both sides of the equation. Then the trinomial that you form by adding the 1/4 is then a perfect square trinomial, and it will factor into a binomial squared. Now the equation of the circle is in standard form. So I'm going to write it right here. So it was x minus 1/2 squared plus y squared equals 1/4. So y'all should be able to tell me what the center of the circle is. Positive 1/2, 0. And then the radius is the square root of 1/4, which would be 1/2. And you need the center and the radius to graph your circle. So your radius is really, really small, so I probably draw my 1 units kind of big here. And I would go to the right 1/2, up 1/2, left 1/2, down 1/2, and sketch in my circle. Oh my gosh, I can't believe I did that. Forget that I just did what I did. Sean's right, I'm wrong. He's smart, I'm not. I'm an idiot. Thank you, Sean. My center is not at 0, 0. I just wanted it to be. My center is at 1/2, 0. Just right here. Right 1/2, up 1/2, left 1/2, down 1/2. There we go. Whew. Hope y'all's circle looks better than mine. Okay, 2 more. Let's get through this. 2 more. We can do it. 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 All right, number 70. All right, so if you have any idea about what we're doing, maybe some of that has attached to your brain and you can make some decisions on your own now. So R is on the left, sine is on the right. If you're thinking that R sine of theta could turn into a Y, it can't, because R and sine will never get multiplied together. So this is where you want to turn that R into an R squared. So multiply both sides by R. And you're going to get r squared equals -4. And I like to squeeze the r right in front of the sign. So that reminds me that I do have r times sine of theta. Then remember, you're supposed to be able to get everything turned into x's and y's. So the r squared turns into an x squared plus y squared. And you have to keep the -4. And then r sine of theta turns into a y. So now everything is in x's and y's. At this stage, you go, oh, it has an x squared and a y squared. They're both positive. They have the same coefficient. So it's going to be a circle. But the center's not going to be at 0, 0 because of that -4y. So you're going to have to bring the 4y over to the left-hand side. You're going to put it to the right of your y squared. So remember, it'll be a plus 4y when you move it over. You don't have to complete the square with your x's because you just have a little x squared term, but you are going to have to complete the square with your y's. So what is 4 divided by 2 squared? 4. So if you add 4 to the left, then you have to add 4 to the right. 4 divided by 2 is 2. 2 squared is 4. That's where I came up with a 4. The x squared just comes down, but your y's are part of a perfect square trinomial, which are going to factor into what binomial squared? Y plus 2. Anybody need me to refresh your memory on how to factor a perfect square trinomial? You take the square root of the y squared. The square root of y squared is y. You take the sign only from the middle term. So that's where the plus comes from. And then you take the square root of the 4, which is a 2. Okay. So now my equation is in standard form. I'll just subtract or erase up here. My center is going to be 0, -2. My radius is not going to be 4, but the square root of 4. So my radius is going to be 2. And we'll sketch this one out, and I'll try my best to get the center right on this one. So the center is down 2. And then the radius of my circle is 2. So I go to the right 2, up 2, left 2, down 2, sketch in my circle. Last one. I'm going to let y'all do this one all by yourself. I'll get you started. And then we'll see how far you can go on this one. All right, everybody got 70? All right, last one, 72. R is equal to 8 cosine theta plus 2 sine theta. All right, R's on one side, cosine's on the other side. No way R and cosine are get multiplied together. R's on one side, sine's on the other. So let's go ahead and we're going to get an R squared in this one. Okay, so R times R is R squared. And then you're going to have to multiply R times 8 cosine theta and 2 sine theta. So you'll write that. So the R and the cosine will be side by side. That will help you remember what to do next. And you also have to multiply the R times 2 sine of theta. So that'd be 2R sine of theta. So these are your notes. And you might want to say, hey, I multiplied both sides by R. All right, go for it. That was my hint. Turn everything into X's and Y's, put it in standard form, and get the graph. I'll pause the video for y'all. All right, any questions about 72? Could you do this problem on your own? Hopefully now since you've seen it, you could.